Hey guys, we're going to get started. You can take a seat. So, thanks once again for coming to today's meetup. We have a great presentation today. Before you start, just a few announcements. So, we have a Spark meetup on Tuesday. I don't know if you know about it, but it's going to be our first Spark talk. It's going to be here in Cross Campus. We also have a WAN Disco meetup on October 6th. That's going to be across campus as well. On October 9th, we have a MAPR meetup at Velocify. November 6th, we have another HBase meetup at Factual. November 12th, we have a MAPR and a Brigade meetup back here across campus. And November 18th, we're actually doing a Spark tutorial that's going to be at Directive. So, before we get started, just a show of hands. How many of you get the newsletter I send out every Thursday? How many of you read it? No worries. Okay. Before we get started, I just want to bring on the sponsors who have helped contribute to this event. And just before we get started, how many of you are attending Hadoop World out here in New York City? 2, 3, not many. That's fine. And have you heard of datascience.la? The website started by Salad and Ed. How many of you heard about it? Not many, alright. That's fine. Okay, let me just bring on a sponsor and we'll get on with the show. So first we're going to bring on a Connexity. If you haven't heard of Connexity, that's because they were probably known as Shopseller until about a week ago. So we're going to have someone come up and just talk. Shuni from Connexity is going to come and give a brief talk about it.
Good evening and welcome everyone. So I'm Srini Swami from Shopzilla, that is now Connexity. We used to host this late hub earlier, like we started like two years ago, I guess, and then now it's here across campus. So we recently rebranded to Connexity, like from Shopzilla to Connexity. So just want to give a quick look back on what is Shopzilla and before that and then now. So actually, this company was started in 1996 as a binary complex, and then started BizRate, that is rating services, and then it became like a leading comparison shopping, Shopzilla.com, and then now it's like transforming into Connexity. Like it's an evolution. Like basically, like from comparison to this is like a broader marketing solution company. So now we offer kind of like paid search, marketplace, and then display media, and then also ratings and insights and all the stuff that we used to do earlier. So this is the company like Connexity now. And so how we are related to Hadoop, right? So we started like Hadoop like four years ago or in Shopzilla, now Connexity, and then we have a lot of projects running in production systems running in Hadoop. So I'll just quickly go through a few of those. Like we have, before that, like the data-wise, like we have really big data. So we have like 100 billion requests per day. That's a real-time bidding happening, and then we have like 40 million unique visitors and all this stuff, and then 100 million ad impressions per day. It's again like a Connexity. That's a advertising platform. So this is like really we have big data going on. So we have multiple projects, right? So just quickly, high level, like what are the technologies we use, right? As usual, like all the Hadoop technologies, like we have like Hadoop Hive running on multiple projects and multiple applications are in production live, and then we have like currently we are building a platform for offer processing, and that is like VolDB, Kafka, and then there is a big Avro solar based one, and then we also have like the real-time bidding that uses the Redis HBase, and then that's the one that serves 10 billion requests per day. So, and then also like we have like an audience estimation that is like that's an analytical thing, and then that uses Mahout, and then we have a keyword scoring application that uses Pi and an R. So we have like a variety of big data solutions, and then also like we are exploring other things like Spark and then Parquet for real-time initiatives. So again, back to this, like if you guys are interested in joining this, so please send your resumes to jobs@connectcity.com. So we are a mid-sized company located here in Santa Monica, and then we are passionate about data. So if you're interested, please drop your resumes. Thank you.
Thanks, Srini. Now I'm going to invite BigData.com, who's also one of our sponsors, and they're going to do a short presentation.
Hello everybody, thank you Subhash, thank you Cross Campus. Our company is Big Data LLC, and what we are is we're a firm that has identified a big niche, a big vacuum in the marketplace, and that being a shortage of good big data resources. So what we decided to do was start a Hadoop training center, and our first one's in Calabasas, which is home of Kardashians, home of big data. And so we have that going. We're providing data scientists for companies that need them, Hadoop developers, administrators, and QA testers as well. So niche in the marketplace, vacuum, so we're trying to see if we can't fill that void. This is Sam, my partner.
Thank you, Steve. Subhash, thank you very much for giving us this opportunity. It's a pleasure to be here again. This is our second time we are here sponsoring this LA Hub. It's a great opportunity to be here. Like Steve was mentioning, we have this training. This is actually, we have completed 2 batches, and we're going to start the 3rd batch very soon. And this would be a great opportunity for people who are looking for basic training, and also at some point, you know, the market is very hot right now, as you all know, and there's a huge shortage of Hadoop developers and administrators. So we would like to invite you guys to go onto our site, which is www.big-data.com, and send us email, and we will be more than happy to sign you up for the upcoming training. Thank you very much, guys. Thank you.
Thanks, Sam and Steve. So now we're going to have a presentation. I'm going to invite Phelan from BlueData. So just a quick bio. Tom graduated from UC Berkeley, and he has spent several years in virtualization. He was at VMWare before he joined BlueData as a co-founder and chief architect. BlueData was in stealth mode until about last week, and he's going to talk about what they're doing with the services they offer. Please welcome, give a round of applause to Tom.
Thank you, Subhash. So today I'm going to talk about various types of Hadoop environments and what kind of use cases are best adapted for each of those environments. I will avoid talking about BlueData because this is a generalized talk, so this won't be a sales pitch. Even if you want to talk to me about BlueData or Darren, you can talk about that after the presentation. I want to also make this as interactive as possible, so even though the lights are pretty glary here, if you have any questions, please put your hands up and we can address them as we go along. Okay, thank you. So rather than giving it this big complex name of discussion of Hadoop, we can talk a little bit more me try it again. Or we can also reduce the I didn't? Okay, good. Okay, we also call this how I virtualize my Hadoop cluster. Before we start, I want to talk about some definitions, because often people have different definitions about what they're talking about. First thing I want to talk about is bare metal cluster. The bare metal refers to when you're installing a Hadoop distribution directly on the hardware itself. So you have an Intel box server, you have an operating system, typically Linux. On top of that operating system, you install one of the many Hadoop distributions, typically Cloudera, Hortonworks, maybe even Apache or a MapR distribution. The software itself is Hadoop. It consists of two primary systems. One is the file system, known as HDFS. The second primary system is the processing framework. There's two of these. If you're running Hadoop 1.0, you'll typically see MR1, which is the job tracker and task tracker. If you're running Hadoop 2.0, you'll typically see Yarn. It's also known as MapReduce for version 2.0. So this is what we mean when we say that we're installing on either a bare metal system or a physical Hadoop system. I just want to note that one of the things which is often overlooked is when Google wrote the original paper back in 2003 about Hadoop, they were designing Hadoop not for super high performance, but rather for reduced cost. At that time, they were using Oracle or they were using any of the other ODBC SQL databases that were available at that time, and yet they were quite expensive due to licensing requirements. So Hadoop was designed, and it became a parallelism, and it became a high-performance system, but it was originally designed for low cost. Oops. Yeah, I just want to show real quick what another way of looking at the Hadoop server in case the text wasn't enough. We start out with a server and a collection of local drives. We add to that the name node, that's the HDFS management component. We add to that a job tracker, which is the HDFS job management software. And together all those are known as the controller. There's one of these per cluster. There may in fact be two if you're in an HA environment, but for simplicity we'll call it one controller. And then there's a sequence of 0 or more workers. These are the ones that actually do the work. They have the data nodes and task trackers, which are the companion services to the name node and job tracker that are on the controller. When we talk about a virtual Hadoop cluster, things get a little more dicey. Okay? Physical Hadoop cluster is pretty clear. But when we say virtual Hadoop cluster, what we're saying is we're going to install the Hadoop distribution inside a virtual machine. And the virtual machine itself is running on top of probably an operating system or a hypervisor, which is itself running on top of a Intel-based server. So I'm not sure how much knowledge we have about virtual machines here, but a virtual machine is a software abstraction which basically makes an illusion that looks exactly like hardware. And so when a Hadoop distribution runs within the context of a virtual machine, it believes it's speaking directly to a piece of hardware, even though it's not. And the reason we have virtual machines is, for the last 10 or 15 years, we've discovered that we can get much more value out of our hardware by running multiple virtual machines and consolidating the number of applications that we run on those virtual machines on the same hardware. So for the same expenditure of hardware costs, we get more CPU cycles for the dollar. On the third bullet item there, just to make a distinction, when you say virtual Hadoop cluster, virtual machine, you might hear the word private cloud, public cloud. Cloud typically refers to a situation when you have more than one virtual machine, or excuse me, more than one physical machine running virtual machines on the same cluster. So once they spread out past a single box, that's typically referred to as a cloud. And I'll go into the differences between public and private cloud in a few minutes. And finally, there are many types of virtualization, hypervisor 1, hypervisor 2, and then Linux containers. For this particular talk, I'll just refer to virtual machines as any one of these, when in fact typically a virtual machine normally refers to type 2 hypervisor. So to show some more information on the public cloud versus private cloud, public cloud is normally referred to as IaaS, or infrastructure as a service. Typically, you won't know what type of virtualization is being run there. You're just given an instance of a virtual machine to run with. And typically, the hosts are not located at the enterprise's data center. That's what makes it a public cloud rather than a private cloud. And data security can be an issue for that reason. That's one of the biggest issues with public clouds today. And finally, they can be expensive. Examples are Amazon AWS or Microsoft's Azure solutions. For the private cloud, many items are exactly the same as the previous one for public cloud. The biggest differentiator is that the physical hosts are located within the enterprise data center. Now, that may not be always precisely true. If you're working with rack space, for example, and you host a rack at their site, that's the equivalent of running something within your own data center, even though you don't actually control the machines yourself. In this case, the data security is enforced by the rules and regulations of the enterprise rather than those of the public cloud hoster. And finally, that's ever present, it can be expensive to do this. Examples are VMware's vSphere, OpenStack, and CloudStack are the typical private cloud managers that are available today. And talk about a little more about each of the individual hypervisors and what the values of each of them are, compare and contrast them. And I'll just refer to these as their relationship within private clouds, not as their relationship in the public clouds. Okay, so within the private cloud, you can have a type 1 or type 2 hypervisor. And as I said earlier, those are what's typically referred to when someone says generically hypervisor or virtual machine. They typically mean a type 1 or type 2 hypervisor. The difference between those is rather esoteric, and I don't really think it has a lot of value to this discussion, but it depends on how the hypervisor itself is actually implemented, whether it's a 1 or 2. And then this is the same. Typically, the hosts are located within the data center. That's because we have a private cloud. The value of these hypervisors is that they have strong fault isolation. That is their biggest quality. And they have strong resource partitioning. Their downside is that they do have overhead. When we say overhead, they have additional CPU and memory costs, in which you would be paying in addition to that required for your application to run. And finally, this is the same sort of slide showing the positives and negatives if you're running containers. Okay, and in this case, containers will have a weak fault isolation. What that means is if you're running an application such as Hadoop within a Linux container, and there's a fault within that container, it will probably bring down the entire server. There's no containment of that fault. Now that's improving, but the state of the art today with containers is that it will bring down the entire server. They have some resource partitioning, not as powerful as hypervisor-based virtualization, but they do have a much lower overhead. Again, that's their true value, is that they're a lot lighter weight in terms of memory and CPU overhead than the hypervisors themselves. And these are the examples of those today: Docker, Mesos, CoreOS, and of course, Linux containers. Now, before I go on, I'd like to ask for any questions about, I presented a lot of information about public, private, hypervisors, and containers. Are there any questions about the definitions? Okay, what's the difference between a container and a hypervisor? The difference is how they do virtualization. Okay, with a hypervisor, as I said earlier, they produce the full illusion of a piece of hardware. Okay, that's a hypervisor. A container does not produce the full illusion of a hypervisor. What it produces is a segment within a running operating system. So it'll look like an application to you, okay, or to if I was running Hadoop within a container, that Hadoop distribution would be referring to disks and to other processes and to networking, all of which are supported by the primary OS, the operating system running on the hardware, not a guest operating system running within a hypervisor. So that's the primary difference.
Which one would be the better, container or hypervisor?
So which is better, the container for Hadoop? Or in general, it depends on your need. So some of the questions that will go on here, but I'll just address it right now, is if I was setting up a public cloud environment, okay, which meant I was selling a service, and I had to guarantee to my consumers a quality of service, some sort of level of service guarantee, so that if their neighbor, who was also buying from me, crashed their VM, I wouldn't take down the entire service, and I wouldn't be using containers. Okay, today I'd have to use a hypervisor. However, that's the pure case for using virtual machines. But if I had another situation where I had just my own cluster or collection of Hadoop clusters, and I would only be impacting myself if one of them crashed, or I could control the software running within those containers well enough, then I would much rather go with Linux containers because of the lower cost involved with that virtualization.
So we can use from the development point of view the container upgradable methodology.
Yeah, absolutely. So the question is, in a development environment, could you use a container and then perhaps switch to a virtual machine or hypervisor at production? The answer is absolutely yes. Yeah. So what I show now is some of the power of the virtualization, things which may not have been entirely obvious in the text discussion. So let's assume that we start with a private cloud. So this is a 4-server private cloud with some disks. And I'm going to stand up a controller virtual machine and then 2 worker virtual machines. What you can see here is that one of the virtual machines is running on one server, 2 of the virtual machines are running on another server, and I have additional capacity for running additional servers out here. This would not be possible in a physical environment. In a physical or a bare metal installation, as we saw earlier, a controller would be running on one server, a worker would be running on a server, and another worker would be running on a different server. So you'd have a different number of physical boxes involved. Now, once again, we start with our same private cloud substrate. Now, if we add some name nodes and data nodes, here's where we can add our containers. So, in this case, a container only has a job tracker or a task tracker. It shares the name node and the data node, which is the HDFS file system. So it's sharing the file system code and it's sharing everything else. And these are the only small pieces of the code which are in the container for Hadoop. So that would be the primary difference if you were to, let's just go back and see that. So here we have we have to have all the services running in each virtual machine because those are individual units and they're operating systems within themselves. But here in containers, since we're sharing a lot of the resources of the individual server on the cloud server, we can get away with running less in the container. Okay. Now, one more thing I want to show is, once again, we start with our private cloud. And we have, in this case, a 4-node cluster. Now, since I have excess capacity, I can go ahead and stand up another cluster. This time I have a 2-node gray cluster. This means I have 2 different Hadoop clusters running on the same set of hardware. And I can get those 2 go away, and then I can add 3 additional ones. So you get a very good flexibility here when you're using virtualized solutions. You can do this in a matter of minutes, switch from one cluster to another cluster with a virtual environment. On a physical environment, that's much more difficult to do. That's probably a matter of hours in order to convert from one type of cluster to another type of cluster. Any questions?
I was going to ask, when would you want to use a bare metal type of
Okay, excellent question. When would you want to use a bare metal type of environment? If you had a very static environment, okay, so if you had a 1,000-node cluster, you had a very large cluster, and you were going to run the same job 7 by 24, 365, day in and day out, maybe like Google or Facebook, you'd be running on a physical cluster, okay? Because they're very static, they don't need to change, they don't get any value from this flexibility. So that's why they would just remain on physical hardware, because that is the fastest and the lowest cost. Any other questions? This is just the one obligatory slide about BlueData. After that, we'll go on. BlueData offers a solution for private cloud that offers private paravirtualization rather than pure virtualization. What this means is we have a hybrid basically between containers and hypervisors. This is the one we have seen before where we have a hypervisor-based cluster. But within the BlueData para-virtualization solution, we take away the local disks, we take away the HDFS, and we have a data connector solution, and then we put the storage back in the base. What we've done is we tried to take the best of both worlds by making the virtual machines lighter weight and leveraging some of the storage capacity in the physical world, but yet still providing the fault containment and resource partitioning that is the value of hypervisors. If you want to talk about this, we can talk about this more after the presentation. I'd be happy to discuss that. But anyway, now that we have our definitions out of the way, let's look at how can we use these definitions and determine when would be the best times to use a virtual cluster and when would be the best times to use a physical cluster. Okay, so how do we go about doing that? These are three things I just threw up on the board here, thinking these are very common ways that people evaluate Hadoop clusters. They evaluate them based on performance, ease of use, and cost. Okay, I would suggest that's the wrong way to evaluate when you're evaluating between physical and virtual Hadoop clusters. So if that's the wrong way, what is the right way? If it's not the right way to ask how fast is a job, what's the cost and how easy it is. Any application can run at any speed if you spend enough money, right? That's just the way it is. So you can get the same job to run on a virtual cluster, you can get the same job to run on a physical cluster, depending on how much money you want to spend with it. And secondly, a tool is always easier once you know how to use it. So there's a learning curve associated with that. And so since we know those two things, we have to look for other attributes in order to find out why it's better to use a virtual cluster or a physical cluster. And since it's hard to come up with questions, I thought we'd come up with answers first. So we'll take some prototypical solutions, try to extract out some commonality, and then those are the questions that we'll use going forward to look at the use cases. I've brought 5 use cases from the real world where enterprises have already done this evaluation. First is, there are multiple clusters and each is lightly used. Well, this is a pretty simple one. This is a virtual cluster is the best solution. If there's one cluster, and it's a big cluster that runs all the time, well, that's a physical cluster. That's what we already talked about that earlier. Like Facebook or Google or LinkedIn would be the case for that. Other answers, if you have a test and dev environment, and what's key about this is that each developer wants their own private play space, but yet that's really expensive when you have dozens or hundreds of developers, and there's no security concerns. So this is ideal for virtual clusters, and in particular, as you noted earlier, it's ideal for Linux containers because you don't need default isolation. And let's say we have an environment with multiple Hadoop applications running on a common data set. And so since there's no expectation of change, then we can go with the physical cluster. Once again, this is a static configuration. And since the configuration is static, that's where we want to keep with a bare metal solution. And one more, this is just a prototypical solution for a public cloud. And as we said earlier, for public cloud, you're probably going to have a virtual hypervisor with a true hypervisor backend. Okay, so now we have given 5 answers. Let's take a look at some answers here, some questions. These are very easy, but they lead to us to some commonality that we can then use to go to more complex situations. So if you have a situation where there are many clusters and they require a fair amount of provisioning and they have short lifespans, they're actually well suited for virtualized clusters. What is incredibly interesting was, I'm not sure how many people read the blog post from Cloudera yesterday. Okay, they had a blog post which said they're using virtualized clusters internally for their R&D department. Okay, just for this reason, because they have a rapid need to provision short-lived clusters. So that's a company that has its bread and butter as a bare metal solution provider is using virtualized clusters internally. So what that tells us is that there are real-world solutions for this. Just depends on finding the right type of situation for it. Flexibility and speed are important. And then the counter argument to that, situations that require few clusters and have long lifespans are bare metal suited, and because you don't want to pay a tax for the virtualization. Okay. So if you want to ask, these are the questions you want to ask when you're thinking about provisioning or designing your next Hadoop data center or your needs is how many clusters will you need over what time? Another way of saying that is what is the lifespan of the cluster? Will the clusters have idle time? What are the fault isolation needs? And what is the source of the big data? If the source of the big data is one single great big HDFS, then you're probably fine with a bare metal cluster. Other questions to ask, these I spell out with an asterisk, is because the impact of these will depend upon the distribution itself. The first set of questions are common across Hadoop distributions. So no matter if you're using MapR or Hortonworks or Cloudera, you're going to have to answer these questions. But if you have the need for specialized job priority, multiple levels of data security like Kerberos, or some more unique billing and tracking system, you'll have to be a little more wary about what distribution you're using. So if you're using Hortonworks, you'll have a certain set of applications to choose from. If you're using MapR, you'll have a different set of applications. So you just need to be careful about those. Now, before I go into the use cases, are there any questions about kind of what we're going to be looking at when we look at the use cases? Okay, so we'll just, sure.
I had a question.
Sure.
Maybe kind of silly. It was going back to when we were comparing hypervisors to containers.
Yes.
And in the hypervisors, they each have their own disk storage, their own virtual disk, whereas the containers were sharing the same data source.
Mm-hmm.
Does that assume then that if you're using containers, you're running like your tasks or your slaves within a container, that they're all accessing the same HDFS? And if it's a hypervisor, they are within like the HDFS and distributed amongst those tasks?
Yeah, it's a good question. So the question is, I may have made an assumption here in the examples where if you have a hypervisor-based virtualization, we saw that we had virtual disks and there was an HDFS file system within that set. Then when I displayed the containers, I displayed a situation where they did not have their own storage, but they had shared storage. So you are correct. In a hypervisor-based virtualized environment, it is typical that people run HDFS within local block devices on those virtual machines. However, they could use the HDFS client. So you're right, they could run with an HDFS client in the virtual machine, and then it would reach out to a remote name node. Absolutely, that's possible. It's just not the common way of doing things. Okay? The same thing with the container is what I showed was the common way, which is that they do share access to a common HDFS database, or excuse me, HDFS file system. But they don't have to do that. You can certainly partition the disks and then have them run their own name node and their own data node within the container, certainly. It's just not typically done that way. But you're right, it could be done that way. Any other questions? Okay, so the question is, what is the normal I/O overhead or payment that you're going to have to pay for a hypervisor? That's a good question. It really depends on a number of factors. For example, if you're using VMware's ESX and their big data extensions, you're probably not paying very much performance at all, right? They're using RDMs, which are the raw disk maps. Almost no additional latency is involved there. The only additional latency would be the difference between running in a software-defined network and a physical network, probably relatively small. Okay, if you're looking at a solution like from Apache Sahara, where you're running with libvirt.io, within a KVM, that's a pretty high penalty because the efficiency of copies through the virtual SCSI stack is going to be pretty high. If you optimize that stack, then you would bring it down. I guess the short answer is that I don't know without looking at the specifics. There will always be a penalty. How big that penalty is, it's not, I couldn't tell you offhand. Okay, so this first use case, it was a large manufacturing company. It was actually based in San Diego. They had only internal customers here, so there was no external customers in play. They started out with one Hadoop cluster, and this was an IT department that stood up this one Hadoop cluster. They had immediate success. They got complete value from their cluster as soon as it came up. But then everybody wanted one, okay, almost immediately. And many of them were lightly used, but they still didn't want to share. Okay, and there were different configurations. Some wanted Cloudera, some wanted Hortonworks, some wanted Spark, some didn't. And they had what they called cluster sprawl. That was their term for what they saw. So what do you think they went with? Anybody? What did they do? Right? That's right. They virtualized in a fast, big way. They virtualized. It was the only way their IT department could keep up with the demand from inside the company. And in this case, that's my addition. They could have used either solution since they didn't have a high security issue. They could have used either hypervisors or Linux containers. All right, looking at the next case. This is a development group within a large tech company. This is a big, big company. Only internal customers again. They had already built out a physical Hadoop cluster. So they had one running in-house, and they were looking to see what they do next. They had no particular data security requirement, no expectation of growth in the future. What would they have done in this case? Container? Perhaps? Probably bare metal would have been the answer, right? So a single physical cluster. The whole idea is that since they have one cluster already and they see no expectation of growth, they can get away, they can say there's no reason to change. They already have it invested in it, and that's fine. Looking at the third use case, that's a large service company with internal and external customers this time, so we have to be careful about the external. They had no internal knowledge of Hadoop, so they're coming in blind. And fault containment and data security were required because they had their external customers here. And the small IT department was tasked for all Hadoop support across the entire company. And there was no way to predict the future because they're a service company here, so they're just trying to do as fast as they can. What do we think it was?
Hire a consultant.
Hire a consultant, I like it. I like it. If they couldn't afford a consultant, what could they do? Right, it's a virtual cluster. So they had to go to the virtual cluster, mostly because they had no internal use of Hadoop and they didn't have enough knowledge to do it themselves. So they went with an automated solution from Hadoop. Fourth use case. Again, a tech company, internal customers, constant stream of low priority jobs. Okay, so that was one set of workloads they had. And then they had a second set of workloads, okay, a bursty stream of high priority jobs. And these were things which actually had to be finished within a few seconds of being issued. So we have a high demand on there, but there was no future growth. And this is a very Hadoop savvy organization. So what do you think they did to solve their problems? Was it a virtual solution or a physical solution? It was a physical solution. In fact, they had two clusters. That was just the way they did it because it was a small enough set, they could run them both. And since they were an IT savvy organization, it didn't cost them anything more to do it. I add that they could have done virtual clusters, but the solution was for them was to use the physical cluster. And number 5, this is a startup company. They were selling an analytics service. That meant that their value add was in their IP around extracting information from data. They sold that data to external customers. They had multiple data sources, ton of security requirements, rapid growth of customer base, but they had no in-house expertise. What do you think they did? Okay, they did virtual, and now what else could they have done? So, did they go public or private? Public or private? Anyone? I would have thought they went private. That's what I would have thought, but no, they went as a virtual cluster and they went public. Okay, so they made the strong trade-off. They made the conscious decision that they were going to deal with the security issues with the customer data and still do it at a public website, or excuse me, a public IaaS offering. So that was one of the ones that surprised me that they went with a public offering. And that's what I have today. Is any questions about what I've presented, about use cases, about how you go measuring stuff?
Do people ever do hybrid solutions where they virtualize like the name nodes and the infrastructure components so that they keep the processing directly on bare metal?
I've actually never seen that. So the question is, has there ever been a hybrid solution where you have your MapReduce processing on physical nodes and your HDFS name node processing on virtual nodes? I've absolutely never seen that. The hybrid that I have seen is test and dev in virtualized environment and then roll it out to the production environment in physical, but I haven't seen a hybrid. Any other questions? All right, thank you very much.
Thanks, Tom, for presenting again. So we're going to raffle off some books. Does everyone have a raffle ticket? Sam there has got the raffle. Can someone please hand out the raffle tickets, please? Just put it in the fishbowl. So O'Reilly sponsored several books today. So let's have a look at them. Does anyone need raffle tickets? Please raise your hand. You need raffle tickets. Good one, right? Anyone else needs raffle tickets? Alright, so we're going to raffle off on HP's book first. I'm going to invite Shin from Connect City to do the first join. $714,383.
Yeah.
Tom? Tom? Why do you put the next? 714409. This is a Hive book. 714409. map reduce design patterns. You're going to get Sam, pick someone. Seven one four three nine three. 714393. Anyone? Let's pick anyone. 714392. Anyone? Okay. Next one. 714390. Okay, 714402. No? Oh, so. So this is map-reduce design patterns. Okay, now we're going to do programming thing. So let me. Yeah, we're going to invite someone from cross campus to do the picking. Okay. 714403. 714403. One. Seven one four four zero six. So, okay, we got a charger, O'Reilly charger. So, actually, it's an extension cord. So, it's you can actually carry this with you if you're in a hotel or something. So, we're going to have this away. So, Darren's going to be the lucky one. Seven one four four zero one. We got several t-shirts to give away. We'll raffle that out too. Oh, you know what? Let me just make this one. I'm just going to throw it. It's a t-shirt. Oh, catch it.
Here we go.
I can't throw it that far. So.
Oh, here we go. Here we go.
We got several books out here if you want to just come and pick it up, just it's free. Yeah. Alright, so that's it for this time. I'll see you on Tuesday at the Spark panel meetup.
So should I talk to David then? David Shirley?
Sure, yeah. Yeah, I mean, most of the talks expect to be technical. I thought this would be technical.
Actually, everything you went through, right?